Today we will be discussing about photovoltaic panels. That is the unit 1.4 in the solar panel installation technicians course. The first topic here is how solar PV panel works. In previous class as well, we have discussed about the material of the from which the solar cells are manufactured. So that is a semiconductor, and most commonly that is silicon. A solar panel, so different. So one solar panel and one solar cell. The solar cells, they are assembled together and they form a solar panel. Means a solar panel can have many solar cells. And together they are converting the solar energy, the light in the energy in the they are receiving from the sun into electricity. A solar cell is a two-terminal power generating device in which one is positive and the another one is the negative terminal. So here in the diagram, both of the metals, positive as well as the negative type of semiconductors are shown. Negative, positive. On the top, sunlight that is falling, and in the outer circuit, the electric current is being generated. Now, step by step, we will discuss about how this solar cell works. The solar panel or the solar cell works on the principle of photoelectric effect. That is the emission of electrons from a material when it is exposed to light. The sunlight is made up of minute particles known as photons, which are emitted from the sun. So when they strike the silicon atom of a solar cell, their energy is transferred to the loose electrons, dislodging them from the atoms. So these photons are similar to in a game. So in a pool game, white balls are there, colored balls are there. So we are hitting the white ball. Then white ball goes and hit the other balls. So the photons, they're similar to that white ball in the pool game. So they transfer its energy to the colored balls when it hits them. So after freeing the electrons, a solar cell needs to direct these electrons into electric current. For that, an electric imbalance should be created inside the cell. So there will be electric imbalance and then current will start moving. Or the electrons will start flowing, that will constitute the current. Now how to create this imbalance? So as the electrons they are tightly packed in a pure silicon. To get these charge carriers like the free electrons or holes, we need to add some type of impurity. So that is the process of doping. So when we are using some type of impurity and inserting some extra electrons, n type of semiconductor is formed. And when we are inserting a lesser number of electrons, so a deficiency of electron, that is a hole, that is caused in the semiconductor, and we call it as a p-type semiconductor. So two types of semiconductors are there, n-type and p-type. So these two types of semiconductors, silicon basically, the silicon semiconductors are placed adjacent to each other within a solar cell. The spare electrons from the n-type silicon cross over to occupy the space in the p-type silicon. And an electric field is created inside the cell as the n-type silicon gets a positive charge and the p-type silicon gets a negative charge. This imbalance is maintained by silicon as being a semiconductor. It can do the work of an insulator. Okay, now we are having an electrical imbalance due to light. The free electrons, they start moving and they constitute the current in the outer circuit. So this type of energy, electric energy obtained, it is clean, environment friendly, and can be utilized to power a number of devices. It can be motors, okay, like for example, it can be motors or other appliances, or also in the satellites. There also solar panels can be installed on the satellites, and we can leave it in the space. Then it will generate its own power using the solar energy in the space. Now coming to the next topic, the panel construction. The solar panel used for electricity generation consists of several solar cells. Okay, that we have discussed. The solar panel may be of round, square, or some other shape. Okay, so the total voltage produced by solar cell, that is less, near about half volt. Now the size of a cell determines the amount of current that the cell can produce. So if the size of the cell is more, the more current will be produced by it. So as a solar cell is producing a lesser number of voltage, and we need a high number of voltage, 12 volt battery minimum we need to power the devices which can do any useful work. For this we make a combination of cells, and that's why a panel is formed. That is the next topic, solar PV panels array configurations. So three type of configurations are there: series connection, parallel connection, and series parallel connection. What is the difference between these type of connections? We have also discussed in our first unit 1.1. Series parallel. In series, the voltage remains across one element, it adds on with the voltage across another element, so voltage adds on in series combination, and current that remains same. Okay, now take a example in this figure. So these two solar cells, they are connected in series, means negative of the first one is connected with positive of the second solar cell. So there it is assumed that their voltage is 12 volt and current is 4.0 ampere of both of these cells. Then the total current obtained at the output for the series combination of these two solar cells, that is still 4 ampere. Current doesn't change in the series combination, whereas voltage add-ons. So 12 volt plus 12 volt, the total voltage in the output, that is 24 volt. So this type of combination we can make when we want to increase the voltage which is available from the solar cell. In case here the voltage of both of the solar cells were the same, but in case of the voltage is different, current is different, then the total voltage will be the summation of the individual voltage, and the minimum ampere capacity will be the criteria for the current available at the output. Now coming to the parallel connection. In case of parallel connection, the across the elements, the voltage that remains the same, whereas the current adds on. So we want to increase the current, then we will use, and then we use this parallel combination. Now taking this example as shown in the figure, so three solar cells are connected, each having the same amount of voltage and current of 12 volt and 4 ampere. So positive of each solar cell is connected to one point in the output, and negative of each solar cell is connected to another point in the output. Now the total output voltage, that is still 12 volt, because in parallel voltage remains the same. Now current adds on 4 plus 4 plus 4, 12 ampere. Okay, now here the three solar panels were having same voltage and same current, but in case if they are different, then the current, total current will be the summation of the individual currents produced by each of the cell, whereas the voltage, okay, the lower voltage, that will decide the this total voltage available. Now coming to the combination of both of these series parallel connections, means both we are using series as well as we are using parallel. Okay, solar PV systems that power large appliances like the refrigerator, they use a 24-volt battery in place of a 12-volt battery. And even more requirement could be there like a 48-volt battery. So if the solar panels are usually designed to charge 12-volt battery, so two panels will be required, both of them connected in series. Okay, because total we want to charge a 24-volt battery. So we need two 12-volt batteries, both of them connected in series. Sorry, both panels. We want to charge a 24-volt battery, then we need two solar panels with the voltage rating as 12-volt connected in parallel. Okay, so we can charge a higher voltage battery or some other load we can feed it with that. The combination of series and parallel connections may be extended to as high a voltage as needed by adding more panels in series. We need to increase the voltage, then we will connect more panels in series. And second, as high ampere as needed by adding more panels in parallel. We need to increase the current, so we will connect the panels in parallel. So the methods here highlighted here, how to connect, make a series parallel connection. To connect the parallels in series until the desired voltage is reached, and then connect more set of panels that are connected in series in parallel until the amperage is reached with the required current level that is reached. First, make a series combination, then check the desired voltage is obtained, then make a parallel combination. Another method, connect panels in parallel to get the desired current, ampere that is current. Then connect more sets of panels that are connected parallelly in series. Means first make the parallel connection, achieve the desired current level, then add more panels in series. So any of the method we can approach while making a series parallel combination for our required voltage and current rating. One more thing here in this topic 1.4.4, the blocking diode and a bypass diode. So diode that is having some terminals we have discussed here, and it conducts in one direction only. Okay, we can call it as a forward bias. So when a diode is forward bias, then it will conduct. Okay, means current is flowing from the positive to the negative side. Then it will conduct. In the reverse happens, then it will not conduct. Then based on this, two type of roles which our diodes will play in our solar panel. We classify as blocking diode and bypass diode. So the name gives us some idea that which type of task or the role this diode has to play. So considering each of them one by one, so blocking diode. Here in the diagram, the battery is there connected with two solar panels. Both of these panels, they are in series. Why they are in series? Because positive of one panel is connected with negative terminal of the another panel. After that, there is a blocking diode. So when current is flowing from the panel to the battery, means the positive terminal of the panel is connected to the P side of the diode. After that, it is connected to the positive terminal of the battery. Means when the panel is giving output, it is producing electricity, the current is flowing out from the panel, flowing through the blocking diode, and it is going to the battery and it is charging. So let us move again to the blocking diode. So the current which is being generated or produced by the solar panel, that is flowing in a way that the diode is forward biased when conducting from panel to the battery. Now the case comes when the solar energy is not available, like in the night, battery is charged, it has stored the charge there, energy is there, so it will start discharging through the panel as well. So as to avoid this situation, the blocking diode is there. Now if the current will flow from the positive terminal of the battery to the positive terminal of the panel, in that case the diode will be reverse biased. because the N side, negative side of the diode, that is connected with positive side of the battery. So the conduction will only in one direction from panel to the battery. So this is the use of the blocking diode, that it will block the reverse flow of current from the battery to the panel. Next thing is the bypass diode. So in the diagram, in the figure 1.4.7, the bypass diodes are connected across the panels. Now where this role of this diode comes, that whenever, like in the case when one of the panel, the solar panel, that is under shade, so no power is being produced, then another panel which is producing electricity, it is under sunlight, it will block the path because both of them are connected in series. So as to avoid this type of situation, the bypass diodes are present. So when the panel is not producing any electricity, but one of the panel and another one is producing electricity in the series combination, so the current will flow through the bypass diode because panel is not allowing any flow of electrons. Okay, in that case, bypass diode completes the circuit and the flow of current is continuous from the second panel to the battery. Factors affecting electricity output of PV panels. So the factors, first one, effect of panel area. So directly it is linked with the electricity produced. So larger the area of the panel, the larger amount of electricity will be produced. Means by the same amount, like the area is doubled, the electricity produced, that will also be doubled. Second thing, effect of sun's brightness. That also directly affects. The brightness of the sun increases, the more electricity will be produced. Effect of panel direction. The maximum electricity that is produced when the panel is facing the sun. So we have to position the panel in such a way that most of the time it faces the, because sun is also moving east to west. So the position where the maximum energy can be obtained, we have to incline our panel in that way, in that direction. Next is effect of heat. This inversely affects the electricity production from a solar panel. So the temperature should be less of the solar panel, that should be less. If it increases, then generated power that will decrease. Mounting of panel. So mounting a panel, how does it affect? Because solar panels are constantly exposed to wind and weather, so it is more important that their mounting is secure and resistant to corrosion or loosening. And mounting panels on a roof is usually cheaper than mounting them on a pole. Yeah, that is okay, because the roof, that is the flat surface, easily we can mount it. On pole it will be difficult. But if the roof is shaded or facing the wrong way, then we need to use a pole. This factors we will affect or the effect we will see in detail as well in our coming units. Okay, next topic is getting maximum electricity from a panel. Okay, to get maximum efficiency, first of all, we must ensure that the panel receives the brightest sunlight. So even if a small part of solar panel is shaded, it loses most of its electricity output. Hence, it is important that the panels are placed at such a location where the sunshine will be available on them for at least 6 hours. Next, it must be considered that over the year, the position of the sun shifts from north to south, as well as during the day from east to west. So we have to take a consideration, because the direction of sun throughout the year is also changing. Okay, then also from daily from east to west. So both we have to take provision. So where the maximum time sun remains, the sunlight is available in that direction, in that inclination, we have to make the position of our panel. The position of trees and buildings on to the north and south of the panel must be considered to make sure they will not cause any shade on the panels at any time of the year. This we have to take care, because rooftop solar panels we are installing, and that rooftop is under shading of the nearby building or trees for much of the time. Then we have to change the direction or the position of our panel. Next is To get maximum efficiency, we have to ensure that the panels are facing towards the sun. Even a solar tracker is available that senses the movement of the sun and changes the face of the solar panel so that it is always facing the sun. Okay, only then it will produce maximum efficiency. Now geographical factor comes here, because everywhere the moving of the panel, that is not practical. Large scale it is not easy. Large panels it is also not easy. So if the panels are fixed in such a way that they face a direction where the brightest sun is located, then they will produce maximum efficiency. So some of the examples are given here in the highlighted areas. A panel located at a site with latitude of 12 degrees north of the equator should be mounted with a tilt of 12 degrees facing the south. Similarly, a panel located at a site with latitude of 18 degrees south of the equator would be best mounted with a tilt of 18 degrees towards the north. Okay, so as per the geographical location, we have to give the tilt of our solar panel. Next factor for increasing the efficiency or obtaining maximum electricity, that is, we have to ensure that the panel is kept as cool as possible, because temperature inversely affects the electricity production. Because sun is hot and we rooftop installation, we have just kept it on the roof, no air gap, then the temperature will be increasing. So the panels must not be mounted directly on the roof, but at least a gap of 10 centimeter should be given between the roof and the panel. That will allow the airflow and reduce the temperature of the solar panel. So here are some of the activities